All right, 8th grade, this is video 3 of lesson 8.1. It's going to cover division. Hopefully you've already watched video 2 with multiplication. This video is going to work the same way, just with the additional step of division being what we're starting with. So if you recall, dividing by a fraction is the same thing as multiplying by its reciprocal. So we're going to take the division problem they give us, we're going to flip the second fraction, make the problem multiplication, and we will factor like we did with multiplication and then simplify our numerators and our denominators. So we'll start here with 4c. Okay, so just like in the last video, I'm choosing to wait until I condense down to one fraction before I start reducing coefficients. So dividing by this second fraction here is the same thing as multiplying by its reciprocal. Okay, and that's the only new step from the last video. Now we bring our coefficients out front. Just like last video, I rewrote all my variables in the numerator and denominator in alphabetical order. I simplified my coefficients, so this is that step you might be skipping once you're comfortable with simplifying these. Reduce your coefficient to 2/9, and then use your properties of exponents to subtract and reduce. So a squared's left on the bottom, a b left on the bottom, an m squared left on the bottom, and there's nothing for the t to simplify with. So the t squared stays on top. All right, so just like that, we're going to look at 4D, another division problem, just real quick, even though it's going to work the same exact way. So here we have dividing by a fraction. So we're going to multiply by that second fraction's reciprocal. Okay, but you'll notice the steps are exactly the same. And so at this point, maybe you're skipping some of these steps and getting to the answer. Some people like to think of it as cross multiplication. Just be careful when you use that terminology. Cross products are technically with proportions, if this was an equal sign. I can see why some students call it that, but technically that's not the process you're using. But you are essentially multiplying the numerator of the first with the denominator of the second here. But you want to think of it as multiplying by the second reciprocal. Okay, so now if we jump to 5 part B, here's where we have the extra piece of factoring first. So I went ahead and factored in my first step and then multiplied by the reciprocal. It doesn't matter which you do first. I just like to get in good habits of always factoring when I can immediately in the first step. So all 4 of these expressions can be factored. Positive 20, factors of positive 20 that add to negative 9 would be a negative 5 and a negative 4. Factors of 21 that add to 10 would be a positive 7 and a positive 3. Factors of negative 12 that add to negative 1 are a negative 4 and a positive 3. And then all we can do in this bottom expression here is just take out the greatest common factor of 6. Then I rewrite it as multiplying by the second fraction's reciprocal. And then I bring them all together, my numerator straight across, my denominator straight across. So here's where you might be able to condense all 3 of these steps into one. You might be able to go from the given problem to the factored expression using multiplication down here in the last step. But don't skip too fast, especially if you're finding that you're getting these wrong. Now we cross off what they have in common. So I'm seeing an x plus 7 and an x minus 4, and I believe that's it. So we write what's left. We have 2 factors in both the numerator and the denominator left. Notice I actually wrote my final answer a little bit more condensed. Anytime we have the same factor repeated twice, it is better to simplify it, but if you were to box this answer in here, I would certainly accept it. Okay, and then for the final piece of these notes, this is where it starts to look pretty intimidating. It's going to bring back a definition that we have not used since 6th grade, and that's a definition of complex fractions. So the way your book describes it, it's a rational expression with a numerator and or denominator that is also a rational expression. That is a fancier math version of saying a fraction within a fraction. So here with guided practice 6, these look rather intimidating, but this here just means we're dividing the top fraction by the bottom fraction. So I just rewrote it, and they are essentially the same thing we just did in guided practice 5. So I changed from a complex complex fraction to a division problem. And then I'm going to take the steps through, just like I did guided practice 5 part B. So I'm going to go through these a little bit quickly, maybe not point out every step. So I rewrote it as a division symbol. I factored. And notice this expression here, I went ahead and there's no actual factoring there. I just rewrote it twice so that I can cross off a little easier. You might not need to do that. You could just use the property of exponents. Okay, here we have a perfect square pattern, so don't miss that. Okay, once everything's factored, then I rewrote it as multiplication by taking the reciprocal of my second fraction. Brought all the numerator, all the denominator together as one fraction, and cross off what they have in common. Not a lot here. There's still quite a bit going on in the answer. We've got 2 binomials on the top and 3 on the bottom, and that's your final answer. All right, and then for our last one, same idea. The factoring for this one might have you a little more stumped just because we have multiple variables. But here, we're going to change dividing 2 fractions using the division sign, and then we're going to factor. So this top first numerator here, this is actually still a difference of 2 squares, even though this isn't a number. So that's going to become x minus y and x plus y. Difference of 2 squares here, y minus 7, y plus 7. The second fraction, there's nothing we can do. It's just going to stay as is. So then we're going to change that to multiplying by the reciprocal and bring them all together as one fraction. Now you might remember this from the first video. When I start crossing off what they have in common, I'm seeing a y plus 7 and a y plus 7. And here I'm seeing 2 factors that are very similar. I have an x minus y and a y minus x. So we said in the first video that anytime you have the same set of parentheses, but they seem to be in the opposite order, that means we can actually factor out a -1. So that's what I have over here in this work. This is the same thing as taking out a -1. And then your x and y are going to change signs. I kind of skipped that step here so I can show you in a little more detail. Y minus x, if we take out the -1, it becomes -y plus x, which is why I wrote it as x minus y instead. Okay, so then I went ahead and rewrote it again and then actually started canceling out what they have in common. Okay, that negative sign out front, I'm just going to leave it out in the front there. All we have left is an x plus y and a y minus 7. Now technically I don't need these parentheses here. I'm not quite sure why I left them there. I could have had them down here as well. But one way your book will probably write answers like these is they're going to go ahead and take that negative sign and carry it through to the numerator. So I'd accept either of these with or without the parentheses. Okay, so this one had quite a few extra steps, but that's the trickiest these are going to get. Okay, so that wraps up 8-1 notes. So if you have any other questions, if you still need my help, make sure you email me.